Hello! Welcome to homework 5.06, solving systems of linear inequalities. Alright, these might be some of the longest problems we do all year long, so it's going to be really important that we kind of stay focused and work through them slowly and make sure we remember all the little steps that we have to do. Alright, so let's take a look at number one. Which of the following points is not in the solution set of the system of inequalities shown to the right? Alright, so which of the following points is not in the solution set, alright, to this system of inequalities? So there are a couple ways you could do this. One is you could actually go and graph these inequalities and then see whether or not the points were in the solution set. Instead, we're going to do this one algebraically. Alright, so they give us 4 points here, and each of these points has an x and a y, an x and a y, an x and a y, and x and a y. So we're going to solve this algebraically. We're going to plug these points in and look for the one that doesn't work. I mean, I know we normally look for the one that checks out, but this is saying is not in the solution set, so we have to plug in the one that doesn't work. Alright, so the first point is 4, 2. So if I take a look at this here, I can plug in the 2 for this y. So I can get 2 is less than or equal to 1/2 times 4 plus 3. Alright, the 4 went in for the x, the 2 went in for the y. And alright, let's see, half of 4 is 2. So I get 2 is less than or equal to 2 plus 3. 2 is less than or equal to 5. Okay? So that first one checks out. You might be saying, wait, they're not equal, but remember, this is an inequality. 2 is less than or equal to 5, so that's okay. Alright? Now, just because the first one checked out doesn't mean that that doesn't tell us enough, because for a system, it has to check out in both. So this might still be the right answer. We're not going to know until we check the second inequality here. So if I plug this one in, the 2 goes in for the y again. The 4 goes in for the x. Negative 2 times 4 is minus 2. Alright, so 2 is greater than negative 8 minus 2. So 2 is greater than negative 8 minus 2, which means 2 is greater than negative 10. Alright, is 2 greater than negative 10? It is, so this one is no good because both of these are true statements. In both cases, these are true, which means number 1 is a solution, but we're looking for the one that's not a solution. So that one is not going to work out for us because it's a solution, so it doesn't work. All right? Let's take a look at number 2 here. All right? So number 2, x is 0 and y is negative 2. So we're going to do the same thing that we just did. Let's put a little line underneath here. All right? So negative 2 goes in for the y. All right? Less than or equal to 1/2 times 0 plus 3. So half of 0 is just going to be 0. 0 plus 3 is just going to be 3. So, is negative 2 less than or equal to 3? It is. So we're good there. Alright, let's check the next one. Alright, so let's plug the negative 2 in for y. So negative 2 goes in for y is greater than negative 2 times 0 minus 2. Alright, so negative 2 is greater than this. Negative 2 times 0 is 0. 0 minus 2 is negative 2. So, if we look at this, this one was true. This one right here is false. All right, this is false because negative 2 is not greater than negative 2. Negative 2 is equal to negative 2. So since this is false, right there, this is our answer. All right? Because for it to be a solution to a system, both things have to be true. Like up here, both were true. That's why we had to cross out number 1. Down here, this side was true, but this side is false, which means it is not a solution to our system. It's a solution to this first equation, but it's not a solution to this second one, so it is not a solution to this system. When you're talking about a solution to a system, it has to be an answer for both. This is only an answer to one of them, so it's not going to work. All right? And if we had checked these other 2 points, you're going to see that both of these would work. I'll just kind of do this quickly here. With this one, y is 3 and x is 0. So this first one would end up being 3 is less than or equal to 3. So the first one checks out. And on this one, it would end up being 3 is greater than negative 2. Both of those things are true, so this one checks out and can't be our answer. If we do this one really quickly, I'm not going to go through the long math of it, but this one would end up being y1 is less than or equal to 4 for the top one, which is true, and it would end up being 1 is greater than negative 6 for the bottom one, which is also true. So you're going to see this is true, this is true, this is true, this is true. So there's really only one that has anything that's false in it, and that's choice 2 there, 0, negative 2, so that would be our correct answer. I know you usually think like multiple choice, oh, that's going to be easier, but here's an example of a multiple choice where there was actually quite a bit of work that went into finding the right answer. All right, so for problems 2 and 3, graph each system of inequalities and label the solution set S. All right, so we're graphing inequalities, so kind of remember what we talked about here. There's sort of a process. You want to solve for y, you want to plot points, okay, and you can do that using a table or slope intercept. You want to think about whether the line is dashed or solid. You want to do your shading. And now we're going to do labels, but we have to label 2 things. We have to label our inequality, and we also have to label our solution. So we've got to label the solution, and we have to label the inequality or the line. Technically a line's an equation, but you know, you've got to label one of those 2. You've got to label not one of 2, but you have to label both of them. All right? So there's a lot to kind of keep track of when we're doing these. All right, so let's take a look at these here. We've got 2 different ones. I'll probably do one with slope-intercept, and I'll do the other one with the table. Let's talk about this one with slope-intercept, because this one can be a little confusing. And you'll notice both of these already have y by themselves, so we thankfully get to skip this first step here. The slope for this first one is going to be 2, which, if we want that as a fraction, is 2 over 1. So that's up to over 1. Now, I knew the slope was 2 because it's the number next to the x. So the question is, what is the y-intercept? Because there is no other number. All right? When there is no other number, the y-intercept is just going to be a 0. So when we go to graph this, we're going to start at 0 on the y-axis, and then we're going to go up to over 1. So 0 means we're just going to start pretty much right here in the center at the origin, because we're not going up or down. And then our slope is telling us up to over 1. Up to over 1, up to over 1, or we can do the reverse, down to back 1, down to back 1, down to back 1. Okay? Now, in this case, there is an equal sign underneath our inequality. So when you have an equal sign underneath your inequality, we use a solid line. When you don't have that equal sign, we use the dashed line. So in this case, this one's going to be a solid line. Notice that I'm going past the points, and I'm going to have an arrow on both sides. So I've done step 1, I've done step 2, I've done step 3. Now we're at step 4, which is the shading. If I look at my inequality here, this is y is greater than or equal to 2x. So when it's greater than, that means we're going to be above the line. But again, if you have a hard time remembering that, you can go to your calculator, 2x, y equals 2x, that was our equation. You scroll over to the left here and you start hitting enter, and then you pick the one that looks more like the greater than sign. All right, that's the one that looks like a greater than sign because the open side is sort of to the left. This is the one that looks like a less than side because the open side of the symbol is kind of to the right. So let's go back to the greater than. Keep hitting enter to scroll through. There's our greater than. And we can see that the shading is up above our line. Now, when we're doing this, you don't want to just color it in really dark because we still have another line to do. Just throw a couple of lines in there to show that you're shading it, but don't go in really dark because we still have another line or another inequality that we have to graph here. Okay? All right, so our second one is y is greater than x minus 1. So if you were doing slope-intercept, your slope would just be 1 over 1, up 1 over 1, and your y-intercept would be negative 1. If you're doing it as a table, all right, we would just go in here and we would type in x minus 1. We would go to second graph, and we would get a bunch of points this way. And there's no decimals here, so it's pretty easy to just find 4 points that are going to work. Negative 1, negative 2, 0, negative 1, so on and so forth. So we could just do x, y, negative 1, negative 2, 0, negative 1, 1, 0, 2, 1, like that. Okay. So if I go to my graph here, remember the x is your left to right, the y is your up and down. So negative 1, negative 2 is going to be back 1 and down 2. 0, negative 1 is going to mean not going left or right at all, but then going down 1. 1, 0 is going to mean going to the right 1 and then not up or down at all. And then 2, 1 is going to be over 2, up 1. And you can kind of see the pattern here. They're kind of going across the diagonals of the boxes. So if you wanted to draw a few more in, just following your pattern, you could do that. So just putting more in, just kind of following the pattern there. Now, we have to take a look. This one does not have an equal sign under it, so when I connect these points, I'm going to be using a dashed line. All right, so I'm not using a solid line this time. I'm using a dashed line to show that there is no equal sign in my inequality there. All right, so I've got both of my lines here. I need to do the shading. Now, because I use the calculator here, it's easy to see which way this one's going to go. I just go to y equals. I scroll over. This is another greater than. All right, so I can do the graph, and I can see that the shading is going to be up above again because it is greater than. So, all right, let's make the shading up above this one. And notice that I keep shading. I don't just shade where the two kind of intersect. I shade the whole thing. So I shade here, I shade here, I shade here. And then even though the lines cross right here, I keep shading. I shade everything that's above this line that's way up here. So if we look at this graph, there's a lot going on, but there's kind of two things. There's this dotted line, and the solution for this one is everything above that dotted line. There's this solid line here, the solid inequality. The solution to this is everything above this. And then the solution to both is where we have this crosshatch. It's kind of where we've got the lines going vertical and horizontal. It's the double shading is what we call it. So we can put our big S right in here to designate that it is the solution. All right, so there's our big S, so there's that label. We also want to label both inequalities. So the solid one was y is greater than or equal to x. The dashed one is y is greater than x minus 1. So if we kind of go through my checklist, I solved for y, that's good. I plotted points, and I used two different methods, I didn't have to. I thought about dashed or solid, I did my shading, and then I labeled my inequalities, and I labeled my solution, and the solution is kind of where we double shaded. It's where the shading overlaps from our two separate graphs. All right, so that's everything that goes into one of these problems. All right, let's take a look at number 3. So we have, again, two inequalities. X minus 2y is less than or equal to negative 4. And then we have this one over here, which is just y is less than 3. All right? Remember, the one that looks like the L is kind of your less than. So these are both less thans. The one, so here, let me actually do that over here. Kind of looks like an L, so that's your less than. And then the greater than, if you put a little loop here, looks an awful lot like a G. So that's your greater than, all right? Less than, greater than, less than, greater than. So these are both less thans. All right, so we go through our steps. Step 1 is to solve for y. On this one, we're not going to have to do anything, but on this one over here, we do have some work to do. So x minus 2y is less than or equal to negative 4. Okay? So remember, that y has an anchor. We're not going to move the y, we're going to move everything else. So we need to get rid of this positive x. So to get rid of a positive x, we're going to subtract x from both sides. These will cancel out. We cannot combine these because they're not like terms. So we end up with negative 2y is less than or equal to negative 4 minus x. Then we have to divide by negative 2. All right, so hopefully a little bell's going off in your head, because with inequalities, when we divide by a negative, you do have to remember to flip this around. So it went from being a less than to now it's a greater than. We have negative 4 divided by negative 2, so that's a positive 2. And then here we also have a negative divided by a negative, so that's going to turn that into a positive. And what you have to remember is that this minus x is really minus 1x. So a negative 1 divided by a negative 2 is a positive 1/2 x. All right, so when we solve for y, it goes from being a less than or equal to a greater than or equal to, and we end up with y is greater than or equal to 2 plus 1/2 x. All right, and again, now you have the same two choices that you usually have. Do you want to do slope and y-intercept, or do you want to make a table? All right, and then the other one, the y is already by itself, so these are the two that we'll actually be graphing. All right, so if we want to graph these, I'm going to do slope and y-intercept for this one. So the slope is 1/2 because it's the number next to the x, and since they're both positive, that means we're going to go up 1 and to the right 1. And then the y-intercept is the number that doesn't have the x, so that's just a 2. So I'm going to start this one over here, up 2, and then I'm going to go up 1 over 2. Up 1 over 2, up 1 over 2, and then the reverse is also true. Down 1, back 2, down 1, back 2, down 1, back 2. Okay, so I've got all my points here. I've got to think, do I want a solid or a dashed line? Well, we have an equal sign here. There's an equal sign under inequality, so that means we're going to want a solid line. So I'm going to make a solid line through here. Okay, I need to do my shading. Now, it started off as a less than, which would have been below the line, but then it's switched to a greater than or equal to. So that actually means we're going to be shading above this line. All right, I'll put my label on right now to just get it out of the way, but make sure you put it off to the side. We've still got another graph to do, so you don't want to put it in the middle of your grid. So x minus 2y is less than or equal to -4. There's my label. Now, let's talk about how we graph y is less than 3. All right, because there is no x here. It's hard to know what's your y-intercept, what's the slope, what's all that. So the way that we graph these is, because it's y less than 3, on the y-axis we're going to go up to 3. So we're going to make our first point up here at 3, and then because we started moving up and down, our line goes left to right. It's always going to be the opposite of the way you start moving. So if it had been, for example, I'm just going to put this down and then cross it out. If it had been x less than 3, we would have gone to the right 3, which means our line would have gone up and down. All right? But because it is y less than 3, it means we go up 3, and then our line is going to go left to right. So I'm just going to make some points here, because we don't want to just instantly draw on the line, because we still have to think, is it going to be dashed or solid? And this one, because there's no equal sign, it's actually going to be a dashed line. That's why we don't want to just instantly make that line, because we do have to think about, is it dashed or solid? And then because it's y is less than 3, we're going to shade everything below this line. So I'm going to shade down here, shade down here, shade down here, shade down here, shade down here. All right, so everything below that line, I'm going to throw my label on it, y less than 3. And then if we kind of go through our checklist here, we've solved for y, we've plotted points, we've done dashed or solid, we've done shading, we labeled our inequalities. We still need to label our solution, which, if you remember, is this area right in here where we have double shading. There was shading for the first one, and there's shading for the second one. So this right here is going to be our solution. So you're seeing there's a lot to keep track on these, so you really kind of have to take your time and make sure that you're going through them carefully. All right, let's flip over to the back. Consider the system of linear inequalities. Graph this system, label its solution set S, and then we're going to determine whether each of these points lie in the solution set. All right, so we have to graph both of these and then see if those points are part of the solution. So the nice thing about these is they already solve for y. So if we think about our checklist, the solve for y has already happened. We still have to plot our points. We still have to do dashed or solid. We still have to do shading. And we still have to do our labels, both for the inequalities and for the solution. But it is kind of nice that we don't have to worry about step 1 here, because both of these are already solved for y. Okay. So, again, we can skip right to the plotting points. I'll do them both ways, or I'll show one way and one the other way. So, this first one here, 2x minus 3. All right. It's in my calculator, so I can bring up the table. Also, because this is an inequality and I'm going to have to do the shading, I might as well go over and look at this. There's a less than symbol, because it kind of looks like an L. So why don't I go over here and set it to the less than symbol, so before I even get started, I can kind of look and see what I'm expecting to get. All right, I'm going to get a line that starts down there, and the shading is going to be below it. So if I bring up the table, now I can actually get my points. So we've got -2, -7, -1, -5, 0, -3, 1, -1, 2, -1, 3, 3, so on and so forth. All right, so we got a whole bunch of points we can use because none of those have decimals. So if I do x, y, why don't I go with -1, -5, 0, negative 3, 1, negative 1, 2, 1, and we'll do 3, 3. So I'm going to do 5 points. Again, 4 is the minimum, but I did 5 here. All right, so when we graph these, x is our left to right, y is our up and down. So negative 1, negative 5 is going to be back 1 because it's negative, and down 5 because it's also negative. 0, negative 3 means I'm not going to go left to right at all. I'm just going to go down 3. 1, negative 1 is over 1, down 1. 2, 1 is going to be over 2, up 1 because both are positive. And then 3, 3 is going to be over 3 and then up 1, 2, 3. Okay, so I've got some points there. Whoops, I think I counted wrong. That was over 4 and up 3. Over 3 and up 3 is going to be right there. So that was a mistake. So as far as kind of connecting these points, we're going to see there is no equal sign under here. So that means we need to use a dashed line. So I've got a dashed line connecting my points here. All right, so there's my dashed line. We already looked at the calculator. This is a less than, so we're shading below. So I'm going to shade below my inequality. All right. And then let's put the label on right now so that I don't forget. So y is less than 2x minus 3. All right, so I've got my label, I've got my dashed line, I've got my points, I've got my shading. All right, if we look at number 2 here, this one will do slope y-intercept. The slope is negative 2 over 3. Remember, slope is rise over run, so because that's a negative 2, we're going down 2 and to the right 3. All right, there's our slope, down 2 and to the right 3. The y-intercept is where we start our graph, and that's a positive 2 because it's the number that is not next to the x. So I'm going to start up 2, which is right there, and then I'm going to go down 2 from that point and over 3. From that point, I'm going to go down 2 and over 3, down 2, and then I actually end up off the graph. I could also do the exact opposite. I can go up 2 and back 3, up 2 and back 3, and I get a whole bunch of points that are falling in a line. Now on this one, we do have the equal sign, so it's not going to be dashed, it's going to be a solid line. All right, so I've got a nice, good, solid line there. All right, so I've done dash solid. Now I have to worry about the shading. This is y is greater than or equal to. So that's going to be above. But again, it's never a bad idea to just throw it in your calculator to make sure that you did everything right. So negative 2/3. And a lot of times kids ask, does the negative have to go outside or inside? It can go on either when you're doing negative signs. Subtraction signs are different. Subtraction signs you're going to want usually outside, but the negative sign can go in either. Negative 2/3 x plus 2. And then, again, this was a greater than, so if I scroll over and start hitting enter, there's my greater than symbol. All right, so when I graph, yep, that looks like what we have, and our shading is going to be up above. Okay, so do my shading up above, up above, up above. Let me throw my label on here. Y is greater than or equal to negative 2/3 x plus 2. And then this section right here is where I have my double shading, so that's where I'm going to make my S. That's the solution to this system of inequalities, where I have the double shaded area. So that's our system. That's the visual representation of our system. Now let's use that to answer these questions. Determine whether or not each of the following points lies in the solution set of this system of any linear inequalities. So this is like the multiple choice that we started with, but instead of plugging them in, we're going to use the graph. So remember with points, x comes first, y comes second. So if we look at 0, 0, that's right here in the center. That is our origin, 0, 0. That one's not going to be in our solution set because it's not shaded at all. So we can say no, not shaded. Right? If we look at 6, 2, that's going to be over 1, 2, 3, 4, 5, 6, up 2. All right, so that's right here. That's going to be a yes because it's right in our double shaded area. So this one would be a yes because it is double shaded. And then let's look at 0, -6. All right? 0, -6 means I don't go left or right at all, and then I go down 1, 2, 3, 4, 5, 6, which is right here. It's in a shaded area, but it's not a double shaded area, so this one would be no because it's only single shading. There's not double shading there, so this one would be a no. All right, you're basically looking for which points lie in the double shaded area. Now, what makes this tricky, these points were all pretty straightforward. The tricky points are a point like this, right here. This point would be part of the solution, and the reason it's part of the solution is because it's touching the double shaded and it's on a solid line. So that's something to keep straight. Solid line and touching the double shading is okay. This point up here, even though it's touching the double shading, because it's on a dashed line, would not be okay. All right, so these are 2 points that are sometimes a little trickier. This one would be yes, because it's on a solid line and touching the double shading. This one up here would be a no, because even though it's touching the double shaded, it's on a dashed line. So that's just something to keep in mind when you're doing these problems. This one didn't ask about that, but if they do, you want to make sure that you have those 2 straight because that can be a tricky piece. Touching the double shaded on a dashed line, no good. Touching the double shading on a solid line is okay. All right, so just kind of keep those 2 things straight. All right, so that finishes what might actually be the longest homework of the year. I mean, these problems take a little bit, so I hope this was helpful. All right, have a good day.